So as we see this week, the outcome of unconstrained natural growth is astonishing. Populations can grow unboundedly and take over the world. This doesn't usually happen, if ever. And so Gause in the 1930s was wondering how populations grew when they were constrained. And he derived the logistic model, which many people use nowadays. And he did these beautiful experiments in paramecium, and they were in test tubes, and he saw how their populations changed over time. And the basic idea was that he started with a few paramecium, say 2, and as time progressed in days, the population grew as though it were going to be exponential, but then the curve leveled off and asymptoted to a given value. In this case, it was 61. And so his formula for the population growth is given here. P of t is 61 divided by 1 plus 31 e to the minus 0.7944 t. This was fitted to the biological data that he collected. And it's a perfect saturating curve, but it's nice because it's got this S shape. And so we're asked to determine how fast the population would be growing at day 8. And now to do this, we need the derivative p prime of t. But before we calculate p prime of t, I'm going to rewrite p of t as 61 times 1 plus 31 e to the minus 0.7944 t to the minus 1 power. This is a handy trick to take. If you know you're going to have to calculate a derivative, you may want to rewrite your function in a way that makes that as easy as possible. And in this case, we want to use the power rule. So now when we calculate p prime of t, we go 61 times minus 1 times 1 plus 31 e to the minus 0.7944 t to the minus 2 power times the derivative of the quantity in the brackets, which is 1 plus 31 e to the minus 0.7944 t. And so we can rewrite this then as 61 times minus 1 times the quantity in brackets to the minus 2 power. And so the derivative of 1 is 0, and then we have plus 31 times the derivative of e to the minus 0.7944 t. And so this equals 61 times minus 1 times the quantity in brackets to the minus 2 power times 31 times e to the minus 0.7944 t times the derivative of minus 0.7944 t. And the derivative of a constant times t is just the constant, which is minus 0.7944. And so this is our derivative. We want to calculate the derivative at time is equal to 8. And so you can put it on the calculator, and you may want to check this. P prime at 8 is equal to 2.35, and the units are paramecium per day. And so this is the rate at which the paramecium population is growing. And you can see by time is equal to 8 on this diagram here, the growth rate is leveling off. We interpret the growth rate as the slope of this line, and it's 2.35.